اهلا يا هيا. يلا خلينا نبدا. Today is Saturday 21st of March. بدنا نكمل gravitational forces. زي ما اتفقنا امبارح هذا part 2. هذا pages 172 to 177. Okay. Yesterday we said that the gravitational force of attraction, not only gravity, the force of attraction between any two bodies is directly proportional to the product of the masses and inverse to square the separation distance between their two center of masses. فقلنا F equal negative means attraction, constant, it's called universal or gravitational constant, universal gravitational constant, which we said it will be given at the end of the exam, 6.67 times 10 to the power negative 11 times m1 times m2 over r squared. We discovered that this force is the gravitational force, is the force of attraction between any two bodies. But if one of the bodies is the Earth, then this force it becomes the gravitational force. It's the same, يعني different names, but it's the same value. And we wrote in OLAB and AS under the gravitational force equal mg. For G is the force over the mass, so it's negative G, the mass over the planet over the radius of the planet squared if you want to find G at surface of planet. But if you want it anywhere above the surface, then it is we do it the same. يعني بس تكون مش radius، تكون radius plus يعني G on space G somewhere on space, not on the surface, تكون negative G mass over radius plus نسميها H إذا بدكم الهاي above the surface by R by H. So if you want to find what is the gravitational field strength at this point, you use this equation G times the mass of the Earth over radius of the Earth plus H. And remember, direction is always toward the center of Earth, because yesterday we drew the gravitational field is always pointing toward the center, it's radial. Okay? Then, today we will see how unit 4 and unit 5 will be combined together in such a problem. ناخذ one question. Let's say a satellite of mass, let's say, equal 2,500 kilogram, is orbiting the Earth at a distance of 12,000 meters above its surface. A. Calculate the gravitational field strength of Earth. Now we know it, 9.81, and at the surface. Now calculate the gravitational field strength of Earth at the satellite's orbit. At the satellite's orbit, يعني at the position of the satellite. Given that mass of Earth equal 5.97 times 10 to the power of 24 kilogram, radius of Earth equal 6.37 times 10 to the power of 6. Oh, sorry. 6.37 times 10 to the power of 3 kilometers. So it's 10 to the power of 6 meters. So you have to change it. Okay. فcalculate G there. هلا كتبنا قلنا G equal negative. If you want to keep it, it's up to you. If you want to remove it, ما في مشكلة. G times M over R plus H square. Now, أنا فاتحه ادخل عليه. أنا ما كنت فاتحه هلا فاتحه. يلا بستناك شوي. Okay. Negative G is 6.67 times 10 to the power of negative 11 times. Which mass I have to take? Shall I take the mass of the satellite or the mass of Earth or both? شو رأيكم? No. Yes, ما أنا بدي gravitational, find the gravitational field strength of Earth. اصلا الساتلايت ما عنده جرافيتيشن فيلد. يعني انت as a body you don't have gravitation field مع انه theoretically I can calculate it for you. بحط الماس تبعتك بتطلع too small. فلا بناخذ الماس اوف ايرث دائما هاي الماس اوف ذا بلانيت. اذا شو بتطلع؟ times 5.97 times 10 to the power of 24 divided by radius of Earth plus the height above, because he said it's orbiting above the surface. If he said from the center, خلاص, this is the number. It's above the surface. أيوة 6.37 times 10 to the power. Watch out that this is 10 to the power of 6. You have to change it from kilometer to meters. Plus 12 thousandths. And so many students, they forget the square. Don't forget the square. If you do the calculation for me, 9.77. Negative 9.78 kilogram Newton per kilogram. نعم. حلو كتبت negative 9. If you want to erase it, no problem. You can erase it. You can leave it. ما في مشكلة. It means only its attraction. بس طلعوا G 9.81 at the surface of Earth, but at this orbit it's smaller. It's 9.78 instead of 9.81. Okay. Now B calculate the gravitational force between Earth and the satellite in its orbit. Yani when the satellite is there, calculate the gravitational force. What is the gravitational force? We write F equal, we can write negative G M1 M2 over R squared. مظبوط؟ بس هاي all this هاي خلاص we have it. يعني we don't need to write, يعني it's enough to write negative mg, but now m is the mass of the satellite, so 2500 times 9.78, that's it. If you won't use that equation, although still you will get the same answer. 9.78, 24,450. I want to write it to three significant figure. It's negative. It's okay if you want to put the negative. It's okay if you release it, remove it. ما في مشكلة لأنه it's just only a direction. It's saying that it is attraction. If you want to write direction toward the center of Earth, toward the center of Earth. Okay? Okay. C. Calculate the orbital speed of this satellite. Now, does anybody have an idea? Do you have an idea how to calculate the speed? Centripetal force. Absolutely right. So, you'll hear the force of gravity is causing a centripetal force. So G, the mass of the Earth times the mass of satellite divided by the distance squared should equal, this is the total distance, should equal the mass of mean of satellite and of Earth. When you want to find the centripetal force, mv squared over r. The mass of satellite, for m small letter, times the speed squared, this is the orbital speed, over mv squared over r. Now, simply, m small letter cancels out, r squared cancel with r. So here, v squared is equal to g times m over r, where m is the mass of the planet, okay? Not the mass of the Earth, not the mass of the satellite. So v, if the orbital is g times mass of planet over r. So V equal, this equation is needed, and they may ask you to show that this equation is correct. You need to figure it out. So V equal square root of 6.67 times 10 to the power of negative 11 times the mass of Earth 5.97 times 10 to the power of 24 divided by the radius, which is all of the distance, 6.37 times 10 to the power of 6 plus 12 thousandths, and there is no square here because it cancels out there. Yeah, do the calculation for me. إذا طلعت معي الكالكوليتر تبعتي إذا صح بتقول لي إنها 7.9 times 10 to the power of 3 meters per second أو 7.9 kilometer per second. Is it true? Did you get the same answer? Yeah. Hey, listen. Rounded, and I rounded to 2 seconds. Okay. Okay. D. Calculate the period of this satellite. Period means the time needed for the satellite to finish one full cycle or one full circle. How do we do it? Since we know the speed is 2 pi r over t. So t is 2 pi r over v, which is the orbital. So 2 pi r, 6.37 times 10 to the power of 6 plus 12,000 divided by v, which is 7.9 times 10 to the power of 3. Question before we finish the calculation. Do you expect it to be faster than Earth? يعني the time is more than 24 hour, less than 24 hour, equal to 24 hour. What do you think? خلينا نشوف يلا. تطلع in seconds time period, the time to finish one full cycle is 5.08 times 10 to the power of 3 seconds. Divide by 3,600. Divide, نشوف how many hours. It's 1.4 hour. So the time period T نحاسبه في شيء غلط في الكالكوليشن. شوف. No, it's okay. Accepted. 1.4 hour. So this satellite rotates around the Earth within 1.4 hour. It finish one full cycle. So this satellite can be used, for example, for forecasting. If you want to know what's happening to the weather worldwide, كيف بيعرفوا what will happen in Jordan and the United States at the same time? There are satellites that orbiting the whole Earth at very fast speed. Maybe within 1 or 2 hours, it may finish one full cycle, so it can see how the shape of the clouds, what's the temperature, كل شيء. So these satellites may be used as uh, uh, as for example, forecasting satellites, or maybe spy satellites to go very fast around many regions. And if you want to, but what if I want this satellite to be as a telecommunication satellite? For example, like NileSat. What can I do if I want to make this satellite as a NileSat? As a NileSat, this means you need to increase the period to reach 24 hours. Why? Because the Earth is spinning around itself one time within 24 hours. So the planet, this is the Earth, and it is spinning around itself all the time. And here there is a planet, then the planet needs to orbit around the Earth one full cycle within 24 hours, so that your receiver here on the roof, when you put it on NileSat, it will keep finding NileSat, because NileSat is not stationary there. We call it geostationary. Geostationary means it is a satellite that keeps at a constant position relative to the ground. But so it's not constant position, it's constant position relative to the ground. And this satellite must go further apart. يعني it should not be at 12,000. If you want to T increase, you need to increase this one. But if you increase R, the orbital speed will also increase. So this will increase. So they are not directly proportional. And these two are increasing. So this, it's hard to be changed. What is the relation there? Let me show you the relation. Now, since V squared is Gm over R, and R, and let me write, and I want to find equation instead of R to put it there. You will, and V equal 2 pi R over T. So R is equal to V times period over 2 pi. Just put it here. Let's substitute it there. Then V squared equal Gm over, instead of R, V T مظبوط 2 pi R over T, R equal VT over 2 pi مظبوط. Then V squared equal Gm over R. R is VT over 2 pi. هاي يعني عجقة على الفاضي. Okay. Okay. لا أنا كان لازم خليها keep it in terms of t, not in terms of v. Okay, this is true, but يعني we did not reach to anything. Let me erase it and do it again. Do it again. You know, since v equal v square equal gm over r, and v equal 2 pi r over t. Let me make square both sides. V squared equal 4 pi squared r squared over t squared. Substitute it there. حط يلا. هلا substitute. This is v squared, and then v squared equals this. Also v squared is equal to this. Right? So now v squared which is gm over r, gm over r is equal to v squared, which is 4 pi squared r squared over t squared. Now, if you do some cross multiplication for t squared, gn is equal to 4 pi squared r cubed. So t squared is equal to 4 pi squared over gn times r cubed. Since all of these are constant, 4 is constant, pi is constant, g is constant, mass of earth is constant, then t squared is proportional to the radius but cubed. This is one of the Kepler's laws. Yani as a statement, it's not required so far, but the equation, the relation is needed. So if you want to increase the period, you need to increase the radius, but not directly proportional. It's within this equation. Then we have to show this. The derivation is important here. Okay. Now, may I erase? Note, a geostationary satellites are satellites that have constant position relative to Earth. These satellites must be orbiting the Earth above the equator. Above the equator يعني خط الاستواء, with a time period equal to the time needed for Earth to spin around its axis one time, which is 24 hours. So you need to know certain periods, like the time for the Earth to spin around itself, one full cycle is 24 hours. The period for the moon to orbit the Earth is considered to be 30 days, مش 31 ولا 29, خلاص 30. The time needed for the Earth to orbit the Sun is 365 days, and all of these must be changed to seconds. Okay? So these satellites are called geostationary. They have to be orbiting the Earth above the equator because the distance between the Earth and the satellite will keep constant when it is above the equator. But if it's above anywhere, not above the equator, distance keeps changing because the Earth is not vertical like this, it's inclined a little bit. So above the equator, it's above the certain distance. Above here, it's not the same distance all the time. But everything will be changing. So all geostationary satellites, they have to be above equator. You may ask me, how many satellites are orbiting the Earth? Let's Google it. How many satellites are in space? You know, there is a huge number. Currently, have over 2,218 artificial satellites orbiting Earth. There is a huge number of satellites that are orbiting the Earth. And how they don't collide with each other. In fact, there is just like a map for them. So everybody wants to send a satellite needs to say where he will put it there. And these satellites, in fact, they can't keep there all the time. Sometimes they lose. Because they are not functioning anymore, so they may lose energy and be just released on the space, or sometimes they fall to the ground, to Earth. Yani, we have a problem with satellites, but this is the case. Okay. Now here, if I ask you question 2, at what height a satellite should be at what height a satellite should be from Earth's surface if it is meant to be a geostationary satellite. Geostationary satellite, like few bracket, maybe we can say it's like telecommunication satellite. Telecommunication satellites. Telecommunication satellites, they have to be at fixed position relative to Earth. So at what height they should be? Let's use the numbers from question number 1, okay? I don't want to write the numbers again. We said that t squared should equal 4 pi squared r cubed over gm. So I want r is the third root of g times n times t squared over 4 pi squared. So the radius should be the third root of 6.67 times 10 to the power of negative 11 times 5.97 times 10 to the power of 24 times 24 hours times 3,600 seconds. All of them are squared divided by 4 pi squared. You have a better calculator, please do the calculation for me. I will do it, but just in case. إذا طلع معي صح radius 4.22 times 10 to the power of 7 meters. This is what did you get with me? Okay, this is not the final answer, you know. Now this is the radius from the center of Earth. Now I want what is the height? Should be from the surface. From the surface, so you have to subtract the radius of Earth. Right? So the height should be 4.22 times 10 to the power of 7 minus 3.67 times 10 to the power of 6, and the answer will be 3.59 times 10 to the power of 7 meters. Let me check if this number is right from Google. How high a geostationary Yes, very close. 3.58 هم كاتبينها 3.59. This means our question في شوية rounding. Yes. طيب, listen to me. Does this mean that all satellites to be geostationary they have to be at this one? Yes. طب how about if it's heavier satellite or less mass satellite? Look to the equation. It has nothing to do with the mass of satellite, only it has to do with the mass of Earth. So if it's meant to be orbiting the Earth, then the mass of satellite is not important. So whether we have big mass, smaller mass, all of them they have the same. So this is بلا عشان هيك قلت لك there is a map وهدول they are orbiting by the same speed عشان to be stationary. فانت let's say this is Earth. At this distance, this is 3.59 times 10 to the power 7 meters. So here, let's say this is Nile-Sat. If you want to put the Arab Sat, you have to put it somewhere here. If you want to put hot bird, you have to put it here. If you want to put Sohail Sat, should be here. Okay? But all of them are at the same radius, so all of them are moving by the same speed at same height, so they keep at relatively at same position. So if you are here هلا إذا أنا هون, if this is my house وباجي أنا بجيب technician, I want بقول له find for me Nile Sat, he will put it like this, high Nile Sat. If my house is here, he has to change the position till here. So people in the United States, they can see this Nile Sat. They have another Nile Sat, it's somewhere here. هذا بسموه Nile Sat 7.0, هذا بسموه Nile Sat use 4 point something. Okay? But it's not the same Nile Sat. If it's the same, they have to use some reflectors, which is impossible, or whatever. So this is, so as the Earth is spinning around itself, as orbiting around itself, these are still orbiting around the Earth by the same speed, keeping at the same height. So the geostationary satellites are this number. They can be spread somewhere here. Okay. Okay. Yani, I believe. Wait. I believe it's enough for today. We did a good job يا جماعة. هلا so far we're almost done with Unit 5. We still have the last thing to do there. So not tomorrow. I don't want to meet you tomorrow. I want to meet you after tomorrow because I want more time with grade 11 and we are a little bit late with grade 11. So I want and grade 9. So I'll spend more time with grade 9 and grade 11. So we will meet on Monday, not on Sunday, on Monday. And we are doing very well. After we finish this, we will solve some questions about it together. Then I may send you an exam to do it on your own and send it back to me. And we need to study more about paper 6. I know there are some calculations in paper 6 that we did not meet before. Okay. يلا يعطيكم العافية. سوري حبيبي.